So this is the part of the show where I highly recommend everybody, wherever you are, you go like this, you go like this, and you go like this. You pretend to buckle yourself in for the roller coaster. That will be this next 30 minutes. Sweet. Okay. So, and then, by the way, at the end of this, for participation, I'm going to ask like a question that's relevant to this, and you'll answer. And it's like, it's not like, don't freak out, or like, you don't have to pay super attention. It's not a quiz, but just like, it's based on this stuff. So yeah, I recommend sitting back, hanging out, paying attention, and all that stuff. So this is an overview of modern industrialization. So essentially, this guy's take, our friend David, his take was that to understand the language of medium engineering, you have to take three kind of perspectives, right? You can think of it scientifically. So, and that kind of gets to the formulas part, right? Of the power of a formula in representing like, what is the real scientific understanding and what does it mean for us? And how does that relate like different concepts to also the social impact and or like the public health impact? So we'll talk about that. And then there's also the social, right? So what does it mean in the context of like our society and for people? And then the symbolic, which is like the vision of technology, and how does that change how we view technology and our vision for the future? And so this is kind of wild to think about. Like the main takeaway of this of technology in the past couple hundred years is that our lifestyle as humans has changed so much, which is honestly pretty mind-blowing when you start to look at it. And then also it's even more mind-blowing because if you read like ancient literature, like, I don't know, Gilgamesh or like the Bible or like anything, like what's crazy is like the concepts and the discussions that make humans humans, like the things that we like are in our humanity are very similar to like even ancient times, but just like the context for our societies is unimaginably different. And I just think that's so amazing. So hopefully that's fascinating to you. But so there is this like painter in Europe, and at this time the European people were not super happy with the Americans because they just kind of got lost that war. And so he painted this painting of what he thought America was like, and he painted this like wilderness, right? There's like all this stuff and like a dead tree, and it's like super uninhabited, right? That was their perspective, was like America's like wilderness. And then and so that was painted in 1828, and then just a few, I guess, yeah. So then in 1846, he painted this next one, and this is the same, basically a repeat where he's painting America, and this is the European perspective, but now it's gone from like in like 20 or so years, right? It's going from like super uninhabited in their minds to now it's like, oh, this beautiful place, and they're like having a picnic and there's people and like things are kind of like I don't know, like massage, and like here, you know, they cut down a tree, so it's like they're making something habitable. And that happened in like a very short span of time. Okay, in the chat, think about what pieces of technology in this time, remember like 1820 to 1840s, can you think of a technology that would have maybe done this? Like what technology do you think is responsible for this change at this time? Just a guess. I'm going to tell you, but you can take a guess. Okay, Henry Ford. Anyone else? Anyone brave enough to offer a guess? Going once, going twice. Okay, I'll give you a hint. It is before the car. Steam machines. I'm liking it. Okay, steam locomotive. Okay, we got locomotive. Okay, yeah, this is good. This is good. We're getting there. Yeah, so essentially, it is steam machines. That's spot on. This is like, so you got steamboats, right? And you have railroad. And this is the type of stuff that really started to connect people on the East Coast, especially, and started to really, for the first time in history, offer opportunities to really connect different communities and societies over large distances. Sweet. Okay, so we're going to get a sense for how fast things change. The other thing to know, besides those kind of three categories, is that David argues for is that there's kind of four ways, right, to classify different engineering inventions. And they kind of have this interplay, but it's useful because it's like the most broken down, most essential part. Like he argues that anything is one of these things, and then they kind of build up into more complicated phenomena. So One is machines, right? And these are both machines. So this is something that has a moving part where it's trying to accomplish motion. So its goal, it uses motion in its purpose. That's the very basic definition that he proposes. And then there's structures, which are basically things that stand still to perform their function. And so this is the other kind of main thing that was going on, right? You have things like bridges, and they're pretty cool. We all love bridges. We all use bridges. Interesting fun fact. So depending on the shape of the bridge, you kind of get a different formula and you get a different requirement at the kind of horizontal force. So this is like one of the first things that people had to figure out in kind of modern industrialization was like, what do we do with bridges? So there's these like cool formulas, and essentially the vertical weight is like you have this distributed load, right? And you have the length of the bridge, and you have the vertical force, and so you have to counteract the vertical force. But then the other tricky thing is like, how do you fasten the bridge in place besides like holding it up, right? Like, how do you stop it from moving left or right? And so if you design it so it's like this, like it bends upward, then you have to push the bridge in because it wants to push out, right? If it's like this, where you're holding the bridge up with suspension, then you have to pull that, and that's what a suspension bridge requires, right? You have to pull on it to keep it up from falling down. So kind of a fun caveat. So these like things also determine how much you have to pay to make the bridge, right? Depending on how much force you need at the end and also the load that it carries. So bridges are cool, and they're an example of a structure that's really important. And then of course you have bridges, you need cars, and cars are machine, right? So all these things start to work together. And then for a car, you need to have a process to make the car move. And so we'll talk about that too, but this is also like the machine that kind of runs the car is in a very simple sense, right? You have a piston that has to kind of move to provide the force that's going to actually move the machine. And so, and here, you have an equation for the piston force, which depends on like the pressure in a piston, and then the area, which gives you the force that it has. And then that's transformed basically by velocity into power. So to get power out of these things, you need to have a force and then you need to have a velocity. And so L here is the length, and then you have the number of strokes and kind of over time, and that gives you the horsepower. So you have to generate power. This is a giant steam engine, so you can get that power and then you can transfer that through a network, right? So if we want to get the energy from one area to another, now you have a network, right, with an input and an output, and you can use that using cables and circuits, right? And you have the whole formula for that, which is power equals the voltage times its current. So you have a generator that creates a voltage, and then you can transform that by current to get power at a distance. And so that is an example of a network. And then once you have that power, you can do interesting things. And this is where we can do processes that we need to create the steel. So now we have a circle, right? Like we have these types of things working together. We want to make the bridge, we need to have steel or iron. And so this is an example of a blast furnace. And this is a very basic version of the chemical process that's going on, where you're basically putting in iron ore, and then you use what's called coke. And this is not cocaine. This is a raw form of carbon that's actually a fuel. And what happens is when you do this in high heat, you get out the raw iron, which is what we can make materials out of. But then you also get this not so fun byproduct of CO2, right? Which has led to our very fun issues of carbon emissions. A common theme with this is that pretty much most of our modern issues come from processes as far as pollution, right? Whenever we try to get something out, usually you have some byproduct that's not super great. So that's kind of fun, and still something we're figuring out. Yeah, and so this is useful for creating these types of bridges. Now that we're able to do this, there's the whole, so this is kind of like the scientific aspect, right? Understanding these formula, but there's also the social aspect. So we can create iron, right? And we can make these public works like the Eiffel Tower, which are really fun and cool. And there's this whole interplay, right, between like specifically structures and the politics of public works like the Eiffel Tower and what they mean for us in society or what we use them for. So structures commonly are tied to that idea of public policy. There's also machines. And so usually machines are oftentimes tied to the economics of private enterprise. So if you have a company, you want to build something or do something really cool, or you sell it, you can kind of accomplish an invention that helps people or something like that. A lot of times machines are tied to economics. So those formula really depend on how you maximize your money, right? Whereas structures can sometimes be, the goal is how do you maximize the beauty potentially, right? If you're building something that wants to be aesthetically cool. And then there's networks, right? Like roads. This is like the interstate system. This can be, mostly tied to connecting people and reshaping regions and people and transportation. And then you have, again, processes, and processes are usually in the balance of private profit and public environment, right? So if you want to have a very high yield and like an oil refinery, like this one that's from Texas and really kind of ugly, right? You're probably going to do a lot of damage to the environment. So there's that balance between doing these processes that are useful and can make a lot of money, but what is the potential risk to the environment around it? So those are all types of things that we've been juggling. Essentially, America's industrialization can be broken down into, he breaks it down into iron and steel and power and speed, which I think are pretty decent categories. Just for context, so I looked into some of Japan's like industrialization. Japan didn't really industrialize super intensely until after kind of the Meiji like Reconstruction period, which is around the late 1870s. So essentially, like this stuff, the steel and like the steam power was like being built, and then kind of when Japanese society started to leave the feudal system and like the shogunate and stuff, they started to send a bunch of people out to Europe and America to like learn about this and catch up. And now obviously fast forward and Japan's like super technologically advanced, right? So everyone's done a good job, but that's kind of like the history. So it's pretty crazy. Like this time period, a lot of this stuff was centralized in more Europe and America, but then it spread very, very quickly around the world. Cool. So in this early area, you have the steamboat, textile factory, which is clothing. You have Eastern railroads. Like these technologies really started in this period to transform society very quickly. Before that, and this is like not even talking electricity, right? Like just for context, like this is like we have very little, and it still blows my mind that like before this time, people were even like getting on boats and just going to other places and like leaving loved ones behind. I don't know. It's just amazing to me how not connected the world was before this period, and still how strong human written record was for such a long time. I think that's really amazing. Anyways, so those are the main things. The steamboat was pretty cool. This guy, Robert Fulton, made like one of the first actually functioning ones. He was also a painter. Back in the day when you wanted to take a selfie, you had to have the chops to paint yourself. And so this is his self-portrait. Pretty dope. Looks pretty good. You never know, like what if like the beauty filter, the first beauty filter was just like you just paint yourself better than you really look. I don't know. So who knows what you really look like. Anyways, and he really liked the Mississippi Basin because there's that giant river, and we purchased it from France in 1802. So it was still pretty cool at this time in the 1800s because it was like new territory. I don't know. You can just buy land back then too. That's like such a weird concept to think about compared to today. Anyways, so that happened. And then the problem was these boilers that were on these steamboats kept exploding. So then he made a huge profit. He switched from painting and tried to fix that problem. And the interesting thing, like this is also kind of another safety versus profit, right? Like these boilers, which heat up water to generate the steam power to then move the ship, they depend on like the pressure, but the stress on it, which is F in here, depends on the pressure and the radius, and then also the thickness of the vessel. And so if you increase your pressure and your radii, like then you're going to make more profit because you're going to have more volume and more power from a higher pressure. And if you decrease your thickness, then you don't have to make as much material. So you also increase your profit. But doing these things is super dangerous. And so as you're building these larger things, you like have this bomb on your boat, right? And it's kind of sketchy. And this problem has continued for a long time. Like water heaters in your house are giant bombs that we just put in our buildings, right? It's just we've gotten a lot better at making them safer and actually a lot better at like the pressure relief system in case things go wrong. So things go wrong all the time. It's just that there's like so many factors of safety now that it's very rare that like you don't hear oftentimes of like water heaters just exploding, which is great. I'm glad they don't. But yeah, so that's kind of this. And a lot of people like, again, there's different lenses to look at this. Like you can, if you want to think about this scientifically, the problem is like the stress, right? That formula. If you want to think about this socially, the problem is like the statistics, right? Like politicians do this all the time. Like, okay, how many boilers exploded in the Mississippi River Basin, and now we have to make like policies about it and deal with it that way. So this happens all the time, right? People engage with technology different ways, or they write about it and make a lot of money, like Mark, I don't know, maybe not money, or get famous, like Mark Twain, right? So Mark Twain is like, oh, all these boilers are exploding. I'm going to make like a great, beautiful novel or memoir about all this stuff happening. Cool. So people deal with this stuff in very different ways. Awesome. And then textiles. This is Francis Lowell in Lowell, Massachusetts. Basically envisioned trying to create the first like modern factory that wasn't horrible to be in, because so many of them were. So that's pretty cool to make clothing. Not super successful, I would say, in some regards, because we still have that issue today. So that's kind of fun to think about. But yeah. And then the next kind of things that happened were the railroad, telegraph, and steel rails that really started to connect the continent. Some better bridges got made, very cool. And better rails got made, very cool. Okay, this part's pretty wacky. So if anyone that's been to the US for like more than a week, probably, okay, maybe a month, would know that like trains in the US are really bad. And so this is why. So the reason this is versus trains in like Tokyo, right, are like insane and amazing and awesome. So this is the trains in 1850. This is the trains in 1960. This is the trains in 1971, which is just like, I don't know, it just kind of blows my mind too. And like, and this is Amtrak, which is very similar to today. Not much has changed. There's just not many trains, and they also are very slow. Like they're not modern. And this is like a huge thing. And this is also part of like kind of the quirks of America, right? Like every president will infrastructure is not very fun to like run on as politicians. So they don't really do that. And then it also takes so long that if you're only in office for so long, you can't really do much. And so it just like kind of keeps getting put back, which is why like our infrastructure is like breaking so much. So there's a lot of political reasons for that too, right? Just the system, but also America's just gigantic, so it's like kind of hard, and you have to like tear it down. So there's a lot of reasons. The reason this happened at this time was because of the car and the plane really started to take off, and so they're like, okay, nobody's interested in trains, so let's just ignore it. But who knows? Will America ever have good trains? To be determined. We shall see. So then next was the cars, and this gets into the Ford stuff. Yeah, exactly. Why use a train when you have your own truck and you can write a country song about it, right? That's a lot more fun. Anyway, so this is Ford and Barney. They made the first cars, pretty cool, and then made the Model T, which is pretty accessible, very fun. This is a painting by someone who was like a futuristic artist, and this was like their futuristic version of the car at the time, which is pretty funny. I don't know, like if you're into abstract art, it looks pretty exciting, right? They drew it with red. It's kind of fun. But yeah, the reason cars picked up was not because they're fast. It was actually just because they were like, you had more freedom and control, which I think given American society makes sense as to why that's popular, right? But yeah, and then in the early 1900s, you had the plane, right? The Wright brothers make the first flyer, very cool. There they are, looking this guy looks kind of almost happy. This guy looks very unhappy, but they made a plane, so it's gotta be doing pretty cool. And then by 1950, like, what are we at here? By 1950, like, I think 1950s, yeah, this is 1950. Okay, this is crazy. So this is the 1950s. This is 1903. All right, like this is when life starts to get real, right? Like we went from like, okay, I made some wood and I got in this plane and it was super dangerous, to like we have an actual like streamlined jet engine. A lot happened. And then by 1969, we're going to the moon. Okay, just for context, like so much has changed so quickly. It's kind of bonkers. I don't think we've ever really fully processed that. And so now with like new technology, right, and like planes and cars, that brought about a new need for power. So things went from like, how can we control these large dynamic systems, to how do we power these large dynamic systems that we're learning how to control. And then control theory really started to take off in the 1900s. And that's a whole other thing I can rant about, but that's like super fun. But anyways, this is Edison, and then this is Rockefeller, and then made, again, very fun oil refineries and got really rich. And then Edison did the whole electricity thing. This is like a painting of him lighting up Madison Square in New York City, which was a big deal. Um, and then this is a painting of someone's reaction to this happening, and it's pretty interesting. Like their response is called the Great White Way, which is fun, a cool name. But this is like their response to electricity for like the first time powering a large area. And it's not really what you think. Like we think electricity is like futuristic, or maybe we're bored of it. I don't know. But this is like kind of I don't know. For me, it's different than what I would have expected someone's first interaction with electricity would have been like. But it's very like cool colors. I think that's pretty interesting. I don't know. I'm not an art major. You guys are probably better at this than I am, but there's a painting. It's cool. And then the Hoover Dam was pretty cool. That was it generating its own power for the first time, which was really interesting. I've been there. It's like really in the middle of nowhere, but it's kind of cool. They like had to pour concrete in some crazy ways. Every single like block of the Hoover Dam is its own thing of concrete that had to be poured at a very weird angle. It's pretty cool if you ever are in that area. Sweet. And then a bunch of other stuff happened. Bridges, more bridges. We love bridges. Okay, this guy happened. Does anyone know who this is? I should have played this game more with these people, but I don't think anyone's gonna know. This is Leland Stanford of Stanford University. I actually haven't, I feel like his picture isn't shown that much. And this is the first like big electrical engineering lab that got really big. So when he founded Stanford, he like knew that electrical engineering was going to be like really important because of this time again of like power and trying to make things smaller and more efficient. And that's pretty much why Silicon Valley exists. Also in my field, Stanford hired a guy called Edward Muybridge, who made the first movie. And so he's also kind of the father of biomechanics in a way, motion capture, and everything that has happened since was derived from this. This was pretty gnarly. Like he put a horse, there was this big fight about horses because no one believed that all their legs were up in the air at the same time. We didn't know. And because we couldn't see it fast enough. And then he put a bunch of trip wires down and just like had these cameras like literally trigger when the horse went over it. So like super, like you can do that in like Minecraft, right? You can like build stuff like that, like very low, I guess, like very easy to conceptualize. I just took a bunch of pictures and put them together and taped them together, and you have your first movie. And lo and behold, the horse does have all hooves off the ground, but they're not like out like Superman, like flying, which was the kind of debate. Anyways, and then this guy was one big person at Stanford too, and then Silicon Valley happened, and then essentially what changed a lot in electrical engineering was there's this thing called vacuum tubes, and there are these giant like analog devices to control the flow of electrons, really more the flow of electricity is a better way of thinking about it, like electrical fields. But you control that, and then you can amplify signals, you can turn them off, you can use a switch, right? That's how we built the first circuits. And that was used in like the original like Turing machine-y thing that was used to decode like Nazi code. So it was pretty interesting. But then that was so big and like annoying to deal with that like, you know, it's just not feasible. And then they made the transistor, which was the same thing, but in a digital way and with basically smaller crystals. And that changed everything because now you can build circuits on a tiny wafer. And now you're like, okay, well, sky's the limit, because now we can build like these things with these giant vacuum tubes on a tiny wafer. You can like imagine now you can make these really small circuits. And now you have the modern phone. So all of that starts to explode. At the same time that that's exploding, our need for infrastructure goes up because we're globalizing. And so now people are like, well, now we need to make bigger planes and bigger networks and better systems to ship things. And now you get, you know, fast forward, here we are, and like super globalized for the most part, still globalizing, but like so much of our lives are just like integrated between cultures and societies and countries in a way that's so interesting and like kind of impossible to untangle, you know, like, I don't know. It's been interesting to see with COVID, like how that's happened. But yeah, so, but this has happened so quick, you know, like really like you can talk to people that have seen so much of this happen. And I think it's just, I think that's still beautiful. So yeah, talk to people that are older than you. You can learn a lot. That's kind of fun. And then we'll end with like, this was, so on the right here is another painting by a Dutch painter of like a kind of like a rural area in the Netherlands. And then this was in 1932. And then on the left, they moved to New York in Broadway. And this was, he painted this And this was kind of like his abstract representation of like the difference between like a Dutch landscape and then a landscape of New York in an abstract way. Again, if you like art, here you go, some abstract art for you. It's pretty cool though. You can kind of get the vibe of like just amount of stuff in area. I think it's pretty cool for showing like the density of stuff. Yeah, very cool. And then here's a modern bridge. Circle back to the bridge. Bridges have gotten really cool. Bridges are great, right? We love them. And then yeah, so that's pretty much most of it. There's a lot of other, I mean, there's so much history out there. So if you want to learn more or like dig in really deep with this stuff, definitely recommend reading those books. Like they're great references. There's so much more. I'm happy to talk about more specific things if there's anything you're interested in. And we'll talk about more like modern stuff through the reflections, which I'll introduce now. Yeah, it's pretty gnarly. Like my biggest interest in this stuff is kind of like more so plainsy stuff. Like at this time, and I can talk about this in another class, maybe it might be fun. Actually, wait, here we go. Like, I guess here, like pretty much at the time of modern computing, there's a like the field that I work in is called control theory, and that's like how do we make stuff do what we want. So it's very vague, but pretty much like a plane, right? It's like how do you make a plane actually fly in the direction you want it to fly? How do you make a refrigerator get hot or cold at the right temperature? How do you make a robot walk in the direction you want? All those questions. And that whole field is also happening at the same time as all this stuff is happening. So if you look at like any scientific field of thought, it's also, you can trace like how it's changed through technology. And some of it started at different times, but some of it's existed for like thousands of years and just like ramped up really quick. Anyways, it's cool, but we can talk more about that some other time.